Let's review how to calculate rebound ratios. So the question is, what will the height of the ball be after the fifth bounce? Given this table, we are told at the start, so at bounce 0, it's 200, the ball is 200 centimeters above the table, let's say. And then after the first bounce, it bounced back to 144 centimeters. That is enough information to find the rebound ratio or the growth factor in this table, and will eventually lead us to how high the ball will be after the fifth bounce. But given this information, we need to find the rebound ratio, and we're going to do that by dividing 144 by 200. So we would do 144 by 200. Definitely use my calculator because you'll have one. 144 divided by 200. And what do we get? We get a rebound ratio of 0.72. 0.72. So that means 200 times 0.72 is 144. So then we're going to continue the pattern down the table. We're going to do the new drop height of 144. And we're going to multiply it by 0.72. And we get 103.68. In the future, we are going to just round to the hundredths place, which is where the 8 is currently. So we're going to take 103.68 and again multiply that by 0.72, because that is how much it is decreasing by each time. So times 103.68 times 0.72. And we're going to round to the nearest hundredths place. So let's do 74.65. All right, and we're going to again multiply it by 0.72. And we're going to round again 53.75, and that again gets multiplied by 0.72. So the answer to the question is not just 38.7. The fifth bounce means the ball will be at a height of 38.7 centimeters. We cannot forget to use our units. Okay, now it's time for you to try one on your own. So here is your problem. It's the same question. So in a minute, you're going to pause the video and you're going to try this on your own. You're going to want to find the height of the ball after the fifth bounce. You've been given enough information. You can watch the video from before, what we just went over, in order to help you solve that. So pause the video now and find the height of the ball after the fifth bounce. All right, time to check your work. So first we need to find the rebound ratio. So we're going to take the rebound and divide it by the height of which it was dropped at. So we'll take 280 and divide it by 350. And we get a rebound ratio of 0.8. So that means 350 times 0.8 equaled 280. So then we'll keep the pattern going. All right, 280 times 0.8 will be 224. And we'll just repeat this pattern. 179.2. All right, 143.36. And this one will round to the hundredths place. All right, so the height of the ball after the fifth bounce is 114.69 centimeters. All right, I'm going to give you even less information this time, and I want the answer to the same question. I skipped a paper. If I gave you the rebound ratio and the starting height, what will the height of the ball be after the fifth bounce? Pause the video here and try this one on your own. All right, how would we answer this? First, I need to make a table. So this is going to be bounce number. And this is going to be ball height. And what are my units? It says centimeters. All right, I need to get to the fifth bounce. I know that from the question. So my table needs to start at 0 and continue through 5. Crooked lines, but crookedly straight lines. All right, so the 0th bounce, so the starting height was 150, and then the rebound ratio was 0.83. So we would multiply 150 by 0.83 to get the next bounce height. So, oops, I put the wrong number in. We'll get 124.5. All right, then we'll take that number and multiply it by the same rebound ratio. And we'll round to the nearest hundredths place, so that would be 103.34. All right, again, we're going to round. The next rebound height would be 85.77. Keep multiplying by the rebound ratio. Next height would be 71.19. And our final time through. Oops, I must have typed something wrong. Is, and we'll round 59.09. So after the fifth bounce, the ball is at 59.09 centimeters high. Hope you found that helpful, and I hope that was a good review for rebound ratio.